So as the people before said, I'm going to be delivering the first session of this global virtual SUGCON. Really happy to be first out of the gate. Hopefully I do it justice. I'm going to be covering an introduction to Docker and containers. Before I jump in, I do just kind of want to reiterate what was said before. We do live in some pretty crazy times at the minute. We've all been affected by this pretty much, I'm sure, but anything that you can donate to help these really worthy causes will really go a long way. It's really, really important. So my name is Rob Earlam. I've been working in a variety of dev roles for about 15 years now. Currently working for Sitecore as a technical evangelist, part of the Sitecore technical marketing team. And yeah, I'm going to cover Docker and containers today. I've got a few things I'm going to go over. I'm going to start off with some basic Docker concepts, so covering what Docker is and how it works. After that, we'll take a look at the Sitecore Docker image repository, showing how you can build Docker images today. And then after that, I'm going to show you some examples of how you can use those images and integrate that into your day-to-day development flow. So let's kick it off by talking about some Docker concepts. What is Docker? Well, I'm going to start by talking about some common issues. Have any of you had any problems ever getting a new project set up on your machine with all the required dependencies it needs? How about managing those dependencies through all of your non-production and production environments? What happens when you need to upgrade on those dependencies? Have you ever mistakenly developed against one version of a dependency locally to discover different versions live in production? I know I've been bitten by that one before. It's quite painful. How about having different team members who want to run different operating systems? Maybe you've got some C# developers who want to run on Windows, and you've got some front-enders who want to run on Macs. What you're talking about here are problems basically because you're deploying the application on its own, and you're relying on the host system to provide the dependencies. And it's kind of a little bit backwards. Really, your host system, your environment, should just be responsible for the OS and not really much else. So really what we're talking about are problems of consistency, isolation, reproducibility. And these are kind of all problems that Docker and containers in general were created to solve. So how do they do that? Well, when you run a container, you're not just running your application. Obviously, that's a part of it, but there's other elements included. You're also going to be running all the dependencies and libraries that it needs, any configuration it needs, and pretty much any other requirements. You'll stand up one or more containers, and they will form a whole complete system, a whole complete architecture for you. And it basically means that your host system then stays really clean. It's not providing any of these dependencies and systems for you. It's all being managed by a series of different Docker containers. Now, the first question a lot of people have when they come to look at containers is, how is this different from a virtual machine? And it is different, but it's different in some subtle ways. Let's take a look at a virtual machine first. So you have your infrastructure. That could be my laptop on my desk here. It could be a VM in Azure. You have a machine somewhere. And on that, you install your host operating system. That could be Windows, it could be Mac, it could be Linux, whatever host you want to run. On top of there, you have your hypervisor. In Windows, that's typically Hyper-V. That's the one that comes out of the box with Windows. And Hyper-V allows you to run virtualization on that machine. So from there, you can start to create virtual machines. I create a VM, and then I install a guest operating system on there. After I've finally gone through all this process, I can finally actually set up my application and its dependencies inside of that virtual machine. And I may have multiple VMs. If I'm working at a partner, I may have different client projects I'm working on with a different VM for each client. It's a pretty typical setup we've seen quite a lot. The problem you have with this issue, with this setup here, is that those orange boxes each represent an entire operating system. So a full version of Windows or a full version of Linux. And the fact you've got there, this scenario, like 4 OSs running on this host infrastructure, introduces quite a lot of overhead. It's quite taxing for like the CPU, the RAM, the disk space especially. So it works, but it's not kind of the ideal way to work. And containers approach this virtualization issue from a slightly different angle. You still have your infrastructure. You still have your host operating system. But instead of using a hypervisor, now we're going to use a Docker daemon instead. And the Docker daemon basically allows you to share the native host operating system elements. So you directly share the kernel from the host operating system, the CPU, and the RAM. All of this is shared directly. So it means you don't need a full operating system provided in your container. And that means the containers you create are much smaller in size in comparison. So because of that, you can create way more containers on the same infrastructure as you can compared to virtual machines. But where do these containers come from? Well, a container is created by an image, and an image is made up of layers. So if we take, for example, a site called XP image, this could be for a content delivery or a content management instance. It's going to be built on top of a Windows Server Core image. And these are images that are provided by Microsoft. In this case, our site core runs against .NET Framework, so it needs to run against Windows. So a lot of ours are built against this 4.8 Windows Server Core long-term support channel 2019 image. And again, you can download this freely today from Microsoft. What we do then is we introduce our own layer on top of this. And this is where the site core functionality comes in. So you can see we build on top of the Windows layer provided by Microsoft, and we add our own functionality on top. But you can take this concept of layers and like layer inheritance, and you can build on top of it yourself. Let's say we then want to create an image for site core PowerShell extensions. Well, we'd have the same two layers in there. We'd have the Windows Server Core image, and we'd have our site core image. What we then do is we build another layer on top of that, and that introduces the site core PowerShell extensions functionality. And you can keep layering on top in this manner. Let's say we want a site core experience accelerator image. Again, we have the same three layers as before, but on top of the site core PowerShell extensions layer, we now introduce the SXA layer as well. So you can see how this concept of layers means you're only introducing your customization each time, and you're building on top of the code that other people have built. You don't have to recreate the world every time. So where do these images come from? Well, you download an image from what's known as a registry. The most commonly used registry today currently is probably the Docker Hub. And if you go on there, you can find images of pretty much any application or development framework you can think of. And then you have your local machine. My laptop's out on my desk here. On there, as I said, I install the Docker daemon, and that gives me a command line interface, the Docker CLI. It also gives me a local registry, and I can issue commands to the CLI to basically pull these images from Docker Hub and store them in my local registry. It works in a distributed model, kind of similar to how Git works in a distributed model for your source control. And you can issue commands to this CLI, and you can just keep pulling down these images into your local registry, and then they're ready to use. So how can we make use of them once they're there? Well, we have Docker Hub. As I said, we have the Docker daemon in my local registry, and I can pull down, for example, the .NET Core image. Once I have that in my local registry, I can then create containers based on that image. And I can create as many containers as I like, all based on that same one image that I've pulled down from Docker Hub. But as I said, you can also start to build on top of it as well. I can take that .NET Core image, and I can create a new image, which includes an extra layer on top containing my .NET Core application. At this point, I've now created a Docker container for my app built on top of the free .NET Core one that Microsoft provide. So I can then take this image and I can create containers based on that. And again, you can create as many containers off these images, basically as many as you have system resources available to run them. So that kind of covers how images, containers, and registries work together. But there's a couple of other key Docker features that we need to touch on before we go into the site core side of things. And the next one's volumes. This is a really powerful feature in Docker. So let's say I've built this custom .NET Core application, and I'm going to create a container based on it. This is running, I'm perfectly happy with it. If I make changes to the C# code, that's a compiled language. So I know that I need to rebuild that image. I need to rebuild the container to get those changes, to be able to view them and interact with them. But what happens if I'm making changes to static assets? Say I'm just doing some front-end work, changing HTML and CSS. I don't want to go over that overhead of having to go through the rebuild process each time. And that's one of the scenarios where volumes comes in really useful. A volume basically lets you share a folder from your host machine to be represented inside the container. So what I can do there is I can share the folder in my solution, which has all my static assets, to the correct location inside the container. And that means that I can then use my IDE of choice to edit those static assets directly in that volume, and those changes will instantly be reflected inside the container, meaning I get a really fast feedback loop. I don't have to go through the rebuild process every time. The other typical scenario around volumes and when you'd use them is for persistence of data. Containers are designed to be pretty short-lived, You create them, you tear them down, you blow them away. So any data you have in the container, you don't want to store in there. If you think about logs, for example, if you store your logs in the container and the container dies, those logs are going to die with it. So you're not going to be able to get any data around what happened there. So a really common use case is persisting the logs somewhere external to the container, and volumes is one way of doing that. Another is around data stores. So from Sitecore's example, you have SQL Server and Solr data, which you don't want to have to recreate every time. So it's common to volume that data out to the host. Then you can basically create your containers, tear them down, and the data is persisted between that action. The other Docker feature I want to touch on is the concept of networking. So again, we have our Docker daemon, our local registry, and our containers. I have my custom .NET Core application, and I can create a container based on it. Now, let's say, for example, I have a SQL Server backend to this container. I could install SQL Server on my host machine directly and have my container communicate with it, and that'd be perfectly valid. It'd be a working scenario. But as I said, I like to keep my host machine as clean as possible. I like to play a game myself where I basically try and install as little as possible on my host, and it seems to work pretty well. So ideally, I want to run it in a container, and Microsoft provides a SQL Server container to do this. So what you can do is you can create another container based on SQL Server, and Docker allows you to create a private network within Docker to allow those two different containers to communicate with each other, meaning that you can create quite complex systems made up of multiple different containers, all communicating with each other and basically forming a whole holistic system within Docker. It's a really nice way of working. So we've kind of covered most of the basics now. I think it's time probably to go and take a look at how this fits into the Sitecore world. So we have a thing called the Sitecore Docker Images repository. Hopefully some of you have heard of this by now. It is an open source GitHub repository, which has been created with an absolute ton of community contributions. I really can't state how involved the community has been with this. We wouldn't be anywhere near where we are without them. And this Docker Images repository, basically you can clone that down to your machine, and it will give you basically instructions on how you can build your own Docker images, your own Sitecore Docker images for use today. Basically, when you download it, you're going to get a heap of configuration and PowerShell scripts. That is what's used to build these out. The main entry point for the repository is this build.ps1 script. And this is the main script which you basically tell PowerShell how to build the images you want and what images you actually want to build. And it's got a series of parameters that you pass into it. So the first two are the Sitecore username and password. These are the only two mandatory parameters for this script. These are the username and password that you use to access dev.sitecore. So the first thing the script's going to do is it's going to hop over to dev.sitecore and it's going to download all of the packages that you need, or that it needs, sorry, to build all these images. So all the WDPs for like XM, XP, Sitecore PowerShell extensions, JSS, SXA, everything that it needs, it's going to download for you. If you have these already on disk, you can copy them into a packages folder, and I'll show you this in a little bit, and that is going to save you a little bit of time on this build process. The next set of parameters are all optional. So these basically control what images you build and how they're built. The first one is the Sitecore version. And by default, it will only build the latest version, so Sitecore 9.3. But we have instructions to build images all the way back to, I think it's 9.02. So you can go back quite far. And you can build multiple versions at once if you want as well. The topology refers to basically our umbrella products. So you can choose to build images for XM, for XP, and also for XC. Again, this is multi-select, so you can pass in any combination of those three parameters you want. The Windows version refers to that base Windows image I was talking about before. By default, we're using the long-term support 2019 Windows image, but there are different Windows versions you want. Maybe you have to use an earlier version of Windows for some dependency somewhere. We have different versions available, and you can switch that using this parameter. The next couple of parameters are what is known as switch parameters, and these are basically true-false toggles, and they control what images are going to get built. So the first one we have is selecting to include images based on Sitecore PowerShell extensions. You can include images based on Sitecore Experience Accelerator. You can include images based on Sitecore JavaScript services. The next one is a little bit of an interesting one. So this whole script is going to build a lot of images. If you select every version, every topology, and all the different includes as well, there's going to be a heap of images that get built. It can take multiple hours to process this. So if you realize you've built some and forgotten some, you can use the skip existing image parameter to rerun this, and it basically will force the script to not try and recreate any that already exist, trying to save you a bit of time. You can select to include experimental images. So some of the images in the repository are marked as experimental. Things like images based off the publishing service is a good example. I think there's a few more coming down the pipe. So this toggle basically sets whether those get built as part of the process as well. The final one we have is registry details. So we touched on registries a little bit before in the Docker Hub. This registry parameter allows you to push the images you built out to a registry. The key thing you must remember here is you've got to push it to a private registry. SUGCON doesn't release any of our images publicly, so you must make sure that the registry you push to is behind some kind of authentication gateway if you choose to do that. So let's look at an example of what images actually get built. Well, we're going to start off by looking at this same base image, the ASP.NET 4.8 Windows Server Core long-term support 2019 image. Quite a long name. When I choose to build XM images for that, I get two. I get my XM content management and I get my XM content delivery. Introducing XP on top of that gives me a few more. I get my XP standalone, which is the equivalent to a content management, my XP content delivery, and then I get my identity server and XConnect. Now there are a few other images that get built, but I'm just focusing on the ones that are off this base image. So things like SQL Server and Solar are included, but that's not going to be on this diagram. Commerce introduces some more. We get things like the Commerce Business Tools and the four engine instances along the bottom. And now with Commerce is where you can start to see the concept of layers and inheritance coming in here. You can see the XC standalone image builds on top of the XP one. Same with the content delivery, same with identity server and XConnect. And that basically forms the basis of what that topology parameter is going to change. So when you set your topology parameter to be XM, XP, or XC, these are the different image variations you're going to get. Once we start to include the toggle params, then things get a little bit more layered again. We can start to introduce cycle PowerShell extensions. Again, you get instances based on XM and XP inheriting from the previous instances, and XC as well. Same with SXA. So SXA builds on top of cycle PowerShell extensions. So we're starting to introduce more layers on top. We can start to introduce cycle JavaScript services as well. When you do cycle JSS and SXA together, you also get combined images. So you get an image which contains both the SXA and JSS functionality included too. And when you include XC and SXA, you also get the option to include cycle SXA storefront, the customizations that provide the custom commerce storefront for you. So you can see how changing those different parameters really do affect like what images actually get built by that build script. Another thing I want to touch on with these images is the concept of entry points. An entry point is basically a command that gets executed when a container is first created from an image. And we have two example entry points included as part of the Docker images repository. The first is for production workloads, and this includes functionality based around logging and monitoring. I mentioned before, you don't want to persist your logs onto disk inside a container, because if the container dies, then you're going to lose all that logs and you're not going to see why it happened. So we've introduced a tool called FileBeat by Elastic, which basically pipes those logs instead of to disk to the standard out. And that means you can use a heap of industry standard tooling to basically collect those logs and persist them outside of the container. The other entry point we have is for development workloads. This basically takes the production entry point and adds some extra functionality on top. The key one being a watch directory script, which allows you to use volumes to basically deploy your code into the container. And I'll talk about this a little bit more in a little bit. So we've created these images, we've run the build scripts, we've got them all sat on our system. How can we actually use them? Well, we want to start to create containers of them. And one of the easiest ways to do this is to use a facility in Docker, which is called Docker Compose. Docker Compose pulls together groups of containers into complete systems. And we have 22 examples just for 9.3 in the repository. So if you go back to the previous versions, there's heaps more as well. We've got examples for XM, XP, XC, and all of the different variants as well. So you can basically stand up full architectures for those topologies and modules just with a single command. It's really awesome. So how does this work day to day in a development team? Well, I'm a developer. I can clone this repository down. I can build these images, and then I can go nuts. I can work in Docker and be super happy. I could then have all of my fellow developers on my team do the same thing. Well, that's not really the best way of doing it. As I said, these scripts can take multiple hours, like overnight sometimes, if you want to build a large enough number of images. So that repetition there really isn't going to work. You need to use that registry parameter that I talked about at the end to basically do the build once, push those images out to a single registry, and then have all of your developers pull that down. And that way you're going to basically only have that build process executed once, and everyone else can get the benefit from it. You're probably going to also use a build server to do that. You probably wouldn't use a development machine. So let's take a look at some of this in action. Okay, I'm going to bring up my browser, and let's take a look at the repo first. So I'm just going to Google site-called Docker images. And the first record you're going to see is the site-called Docker images repository.
Sorry, I don't.
So you can go here, and I think my Google Home is trying to talk to me. So here you can see basically the repository itself. We have the build script here, and you can see, I mean, there's commits from 12 hours ago, like really super recent. It's a very, very active repository. Let's go and take a look at it in Windows Explorer. Let's put an easier way of doing it as well. So if we take a look here, again, we can see what gets downloaded when I do a clone of that repository. The build.ps1 script's there, and there's lots of other different scripts and things and which help you out. One thing I wanted to point out was this packages directory. So as I said, the first thing the build script's going to do is it's going to download all of these packages to your host machine. If you have them on your machine already, you can just copy them in, and it's going to basically skip that whole download process and save you a bit of time, really. So let's take a look at this in PowerShell. Okay, so I'm going to want to actually build these images. Let's go to the right folder first. Oops. So I'm going to run that build.ps1 script. But what I want to do is I want to push it to my registry. And I'm not going to use Docker Hub for this example. I'm going to use a container registry that's in Azure, and that's called Azure Container Registries. The first thing I need to do is run an AZ login command, and that's basically going to just tie the PowerShell window I just had here to basically my Azure account. It's going to go now and collect and enumerate all the different subscriptions I have, and that's going to basically allow me to then interact with Azure. After this, I then need to authenticate with the actual ACR instance itself. And to do that, you do an Azure again, AZ, ACR for Azure Container Registries, login. We're going to go -n, and then the name I gave it was Rob SC Images. Oh, my typing's awful today. That looks good. So what this is now going to do is it's going to go and tie this PowerShell window not only to my Azure account, but also to that specific container registry. It's going to allow me to authenticate with it, and it's basically going to allow me to then basically run that build script, build all those images, and push those images straight into that ACR instance. So I'm going to start copying these commands. It's going to be easier. So I can run a build here, and what I need to do is pass in the registry parameter. And then I use this robscimages.azurecr.io, and that's basically the full URL for that Azure ACR instance. I'm not going to build these now. As I said, it can take multiple hours, and I've only got 45 minutes. So obviously I've built these ahead of time. So what I can do to view those is to go Docker image ls, and that's now going to list all of the Docker images that I have active on my system. So we can see we have images for XP Identity Server, we've got a content delivery image, SQL Server, what else have we got? Oh, we've got some XConnect ones, we've got some Solar down here, all different things that you're used to running every day when you run SiteCore instances. An interesting thing to notice is you'll see that a lot of these are duplicated. So this XP Identity Server image, You can see it's got the same ID, but it's got two different names. And that's because I use the repository parameter when I build these. I've built this image locally, so that's the top one. And I also pushed it out to the repository. So it's the same image, it's just represented in two different locations almost. When you work as another developer on the team, if I just pulled this image, I'd only have the second row here. I wouldn't see the top one. Okay, so I've got all of these images locally. How do I actually create sitecore architectures based on it? Well, let's hop back to the actual Docker images repo again. If we go into this Windows folder, there's a tests folder in here, and then we go into the specific sitecore versions. So I'm going to look at sitecore 9.3, and here we can see all the different Docker Compose files. These are all different examples of how you can create sitecore architectures. So I'm just going to go to the simplest one, sitecore XM architecture. And here you can see basically what makes up a Docker Compose file. We have a series of elements in this YAML document. The first one, for example, creates a SQL container. Then we create a Solr container, CD next, and then CM. If we start with the SQL container, we can see we have the image name we're going to build from, and we have the volume. We're basically saying that /data/SQL, which is a folder in this repository, is going to be represented as C data inside the container. So the data in my container is going to be volumed out to my host. Same with Solr as well. And that's it, basically. So if I hop back to the CLI, if I wanted to actually create a container based on that, I would go into the Windows folder. What was it? It was tests 9.3. And here we go. So that's what we just looked at in Explorer. We can see those files. I can go Docker Compose. So the default file name for Docker Compose is just dockercompose.yaml. Because we're using different file names, you've got to use a -f flag to basically tell it which file to read from. Docker compose.xm.yaml, and then you'd say up to bring those containers up. And then I'd usually use a -d flag to run it in disconnected mode, which basically kind of runs them as a background process instead of tying them to this PowerShell window. Again, I'm not going to stand one of these up now. I'll show you a running architecture shortly, but that's basically how easy it is to build the images and then create a sitecore architecture based off them. So we've got these images downloaded. We've created an architecture on them. We've got an instance of sitecore running, but that's still kind of only half of the battle. We actually need to use this in our development flow. We need to be able to create code, push code to those instances, and have them update and reflect that. So what do we need? Well, I need a GitHub repository. I need somewhere to store all of this stuff I'm going to be working on. I need a custom Docker Compose file. Those Docker Compose files I just showed you, they're all examples. They're all examples showing how you can do something. The idea is when you start developing with it, you're going to take those examples, well, the example which closely fits your target system, and then you'll customize it to work how you want. For this example, I'm going to show you, I'm going to be using an XP architecture with sitecore SXA installed. I need a Visual Studio solution. Obviously, I need somewhere to install my code. I need somewhere to write my code. Standard, that's how we work. And I need to do serialization. I'm going to use TDS for this example, but you could just as easily use Unicorn as well. So what are we going to stand up? Well, similar to that image I showed you before with all the boxes, let's look at what my custom Docker Compose is going to create. I've introduced all 4 different base images I'm going to be working off now. We have a base image for my SQL server, the same ASP.NET 4.8 base image. We have a runtime 4.8 image, and also we have an OpenJDK image. So looking at the XP SXA ones first, we have my SQL dev instance, my SQL server. We have my CD and my standalone, my CM images, and I also have an SXA specific Solr image that I'm going to be creating a container from. On top of that, I have all my XConnect images, so XConnect site and the different worker backend processes as well. So let's try and take a look at some of this in action. Let's hop over to Visual Studio first. So this is the Visual Studio solution I was just talking about. If you look in this solution items folder, I have my custom Docker Compose file in here. And it's quite similar to the one before. I have my SQL image, I have my Solr image, I have the XConnect ones, which weren't there before. I'm not really doing much with XConnect, so I'm just going to skip past those. Then I have my CD and my CM. So So let's start at the top. I've made a couple of changes to how the original ones work, and a lot of these are just purely preference on how I prefer to work, basically. I've changed how the volumes work first. Previously, how I said the volumes are outputted to a folder within the repository. That's what's known as an unnamed volume in Docker. So we're basically telling Docker that I want to put it at this specific location on my hard drive. I've changed this over to use what's called a named volume. And a named volume is slightly different. It still volumes the data out to my host machine, but with a named volume, you're basically telling Docker, I don't care where you put this somewhere on my machine for me, you handle it, and I'll just interact with it via the CLI instead. So that's what I've done with SQL and Solr here. I've created a named volume called Data SQL and a named volume called Data Solr. I jump to the bottom again. You can see those basically get defined at the bottom of the Docker Compose file. I'm going to skip Xconnect, as I said, and we'll basically just focus on CD and CM. So I have my entry point specified. So I'm going to use the development entry point, which is going to allow me to deploy my code. I have some ports specified. This is pretty standard stuff. I've also changed how the license file works. So with the out-of-the-box ones, we have another PowerShell script part of the Docker repository, which basically allows you to store your license key into an environment variable. But I invariably forgot that every single time I started a sitecore architecture. So instead of that, I'm just including the location as an environment variable. Then I'm voluming in my actual license file to that location. And it basically means that it's a set and forget for me. I don't have to remember to set that environment variable all the time. So it's a little bit more foolproof. The next thing to probably look at is the volume. So this is how the watch directory works. What happens is whenever there's a C source folder present inside the container, the watch directory script is going to watch that folder. And any files that get dropped in there, it's going to automatically copy into your root folder. And that's how deployments happen. So what I'm doing is I have a deploy folder in the root of my repository. And that is basically where I'm going to publish my code from in Visual Studio. And that is then going to be volumed into my source directory in the container. The watch script will then take any files and copy them into the root folder. So it's kind of like a chained process, which will enable a pretty typical deployment scenario. The final one is installing the remote debugger, allowing me to actually connect and debug these containers once they're running. Okay, so let's hop back to PowerShell again, and I'm gonna go into that solution folder. Getting started. Okay, so I have my Docker Compose file named as the default name. So just docker compose.yaml. So I don't need to include the -f flag here. And I've basically created these. I've got to spell it right though. So I've basically docker dash. Oh Jesus, my typing is awful today. Docker Compose. Right. So I created these ahead of time just to save up the sitecore warm-up time and everything. Docker's fantastic, but unfortunately sitecore still needs to warm up. What you can use once it's running a docker compose ps command, and that is now going to show me all of my active Docker containers that are part of that Docker compose file. So we can see I have a CD instance, I have a CM, my Solr, my SQL, my automation engine seems to have exited for some reason, but I don't need it for this demo if that's okay. And yeah, the various Xconnect ones as well. The other thing I want to touch on briefly is the concept of IPs and domain names. So each container, when it's created, is given a new IP when it's generated. And you can map these ports in here. So this came from the Docker Compose file. So this is basically going to map port 44002 from my host to be pumped through to the IP of that container, and it appears in that container, basically. I had a few issues around that with TDS. It didn't seem to like working with the port numbers. So I'm using a tool called whale names, which I've got active in here. This is a node tool, which you basically just execute, and it's going to update the host file on my machine to basically map all the IPs of any active containers I have to have domain names that actually resolve. So if I hop over here and open my host file, you can see when you run that, you get this whale names section. So you can see I have basically the IPs of the containers. Then we have the ID of the container that's generated by Docker when it's created. And let's hop down to CD, that's going to be a bit easier. I have the name of the container within the Docker Compose file, so CD. the ID again, as I said, and then this one is a combination of the folder it's in, the name of the container in the Docker Compose file, and an instance number in case you have more than one instances of the CD. I only really care about the CD one. That's the one that's easiest for me to use. And it is easy to use. That means I can hop over to my browser, and this is the site that I've created in my Visual Studio solution. It shows the awesome people from the rest of the technical marketing team. And I can basically go and resolve this site just using CD. I can go into Sitecore and I can use CM, and that will then access the content management instance. I can go into the content editor, and this is just basically a pretty standard SXA site. There's nothing too crazy about it. My site's loaded now. There we go. So we can see it's just a homepage. That's all. We have some custom data items here, which are each of the different team members, some media library images, pretty standard Sitecore content stuff. To render those out, I've created there's a custom rendering in here. So we have a feature called Team List with a team list rendering. So let's hop back to Visual Studio. All that code and that functionality is what exists in these feature and project layers. So if I look at my project layer, I have a website which basically has about 4 lines of CSS in it. That's about it. But the big key here is the serialization piece. So this is obviously where I serialize all of my site information. And as I said, I'm using TDS. And you configure it pretty much exactly the same way as you would do when you're using your host. So my URL is just CM, because that's what my whale names is mapping into my content management instance. I point this deploy folder to the deploy folder for my inside of my repository. And if I take a look in there, so I go into my repository here, I have a deploy folder. You can see this is where I'm deploying the assets out for my solution. So this is where the TDS connector goes in my _dev folder. Just as it would be deployed into my dub root normally, here it's deployed into here. The key thing you've got to remember, you've got to check this enable container support checkbox. Usually when the TDS connector gets deployed, it checks where it's being deployed to make sure it's a valid Sitecore web root. So it's going to look for DLLs and config and the like. This checkbox basically tells it to ignore that and just go, trust me, I know that it needs to go to this location, basically. As soon as you've done that, then you just get standard TDS. It just works exactly as it does on your host. You can go in there, you can sync files, sync items, and work with it exactly as you would normally. So let's take a look at the feature. This, as I said, is pretty standard. I've got the controller rendering, so I've got the Razor view for that. Pretty basic stuff. I've got some repository to get the data, the models, and the actual controller itself, and a bit of config just to wire all this up. So to do the deployment of this, again, I'm just using the out-of-the-box Visual Studio publish command here. You could use something like Helix publishing pipelines if you want as well, anything like that. I just target the same deploy location, that same location where I had the TDS connector pointed to. And if I take a look in here, I can see I have my Razor view in here. I can go back and check, for example, the bin directory. All I have is the Hedgehog DLL, my feature DLL, and the project DLL. So you can see it's basically my development flow and my deployment flow. Once you set up your Docker containers, is pretty much the same as it is when working on your host. But what about debugging? So you need to be able to look through your container. You need to be able to look through your code as well. I'd like to believe that I write perfect code first time every time, but I know that's not true. With the later versions of VS 2019, they've got some really nice container integration. You get this new containers window. And you can see here a list of all the different containers that I have running on my machine. So if we take a look at the CD one first, you get some really nice data output. I can see all of the environment variables that were passed in. So things like all the connection strings that were set, my sole URL, that license that I volumed in before. I can check the port mappings. As we mentioned before, 0.44002 is mapped from my host machine, and I can see that in here. I can get a live stream of logs. So as I said before, that program called FileBeat is outputting the logs instead of to disk to stand it out for the container. That's what this window reads from. So I can go through here and see what looks like loads and loads of Xconnect errors. Awesome. But again, it makes it really easy just to have all that data right at the tip of my fingertips. I love this one as well. This files window is fantastic. Previously, you'd have to open up a CLI, and there's commands you can issue to basically connect into a container. Then from there, you'd be using standard command line commands like dir, ls, and things like that to see what's in the container. This gives you an actual file explorer. So I can go and look at, let's take that watch directory example. Here I can see the mapped in source directory. So this is that deploy folder I talked about before, mapped into my container. And we can see the same elements. There's the TDS connector. I can see my bin folder here, all those elements that I've published from this Visual Studio solution. So the watch directory script will watch that source folder, and any files that get dropped in there automatically get copied into my www root folder. So we can go into the inetpub www root folder and see them in there as well. Here's my TDS connector. We can see that's in there. Let's see how quickly the bin folder enumerates. It's pretty big, this one. Is it going? Oh, that wasn't too bad. Hey, so we can see my feature DLL. So they've been copied in there. So anything I copy in basically automatically gets moved straight into that folder for me. It's a really nice way of working. So the last thing that I want to show here is actually around the debugger as well. So let's attach this. And you can attach the processes in exactly the same way that you do when working with processes on your host machine. You just go attach the process, and this is now going to go and connect to the CD instance I told it to, and it's going to go and enumerate all of the different processes that are active on that machine, or in that container, sorry. So you can now go through when they eventually come up and connect to the processes it's running. Remember, this is kind of like a cut down version of Windows that's in there. There's IIS that's active in there. So we can just go and attach to the W3 WP process exactly as we would when working locally. And of course, it doesn't want to list them out now. This is pretty new functionality in Visual Studio. You've got to have at least 16.5 and above. Let's give this one last try. It did work yesterday for me. Typically what happens is you connect as usual, and then you can just set breakpoints in your code. And then you can go execute the browser, and the code breakpoints will be hit, and you get your full debugging support. So you have the call stack, you have your watch window, your locals window, everything you're used to working with is just there and working as it would do as if you're working locally. Come on. Oh, of course it doesn't want to play ball. Never mind, it does work. So you can see when looking at this from a development flow, you're basically working with Sitecore and your Visual Studio solution in exactly the same way that you would do when it's on your host, but you get all those benefits around isolation, around basically all the speed of like creating containers, speed of creating architectures. You get all of the benefits that Docker provides, but the same like rich development experience that you're used to. Okay, so there are a couple of links I just wanted to show you around this. I've got a few videos that I created on the Master Sitecore channel. There's a couple more Docker ones coming out in the future as well, and you can see those links on there. If you want to access the Sitecore Docker images repository, you can see the link to that there. And the repository that I just showed you, everything that's in there is available at the bottom link. You can clone that repository down today and basically do everything that I just showed you, and hopefully your debugger will actually attach. Okay, any questions?
All right, it looks like there is one question, but it's in 27 parts.
27 parts, nice.
You're gonna be busy for me. No, there's truly only one question. Are there any plans for Sitecore to provide a private Docker registry to pull pre-built images from?
We are definitely looking at having a registry to pull images from, so you don't have to go through that build process yourself. Yeah, basically, yeah, keep watching. It is something we're working on producing for sure.
All right, a couple more questions popped in. Has this been tested in AKS?
Yes, so our demo team internally, they run all the demo software through AKS. Bart Plasmeyer is the man with all the answers for that. I haven't touched on AKS too much myself, but yeah, I definitely know it's been done.
All right, another question is, not everyone uses TDS. Have you hooked up Docker with Unicorn?
I haven't personally. I've only used TDS, but I know other people in the community have. So it's definitely been done.
All All right, we have another question if they're rolling in. How different would the connection to the registry part be if I try to connect to my private Docker registry that comes free with Docker, with the Docker account instead of AZ Docker registry?
So as I said, you've got to make sure that it's the private Docker Hub. You can't push to the public one because we don't want our images going out publicly. And then you basically just have to authenticate with the private version of Docker Hub. I'm not entirely sure. I think it's authenticated through Docker for Windows in that one. So you basically sign into your account in Docker for Windows if you're on Windows. And then that will then authenticate you with Docker Hub and allow you to access your private images in the registry. There's probably a similar authentication method for Windows and Mac as well, but I haven't tried them.
All right, I am not seeing any more questions. Anybody else have questions? Please ask them in the questions window and go to webinar.
Yeah, I think
Oh, here they come. They're all coming in.
there are more coming in.
Is it important to have Visual Studio 2019 to have containers connection, or we can have it through 2017 as well? Because we are using 2017 for Cycler 9.3.
I don't think it exists in 2017. I know you need version 16.5 and above, I think it is, which I think is 2019 only, I'm pretty sure.
And
Yeah,
another
you can
question.
use a community edition as well. Visual Studio Code has a Docker plugin. But the debugging is a bit more problematic. So when you go to debug with Visual Studio 2019 16.5, you get that debugger option. You won't get that with the earlier versions. You've got to go through, and it's slightly longer. It's a slightly longer process. If you follow Mark Cassidy's blog post, that will tell you how to do that on a slightly older version. You've got to go find the IP addresses and install the debugger and run a bunch of other stuff, but it is possible.
All right, more questions. Does it create all the volumes for you in your example today?
What was that, sorry?
Does it create all the volumes for you in your example today?
Yes,
I know
it will create all the volumes for you, everything. You can basically clone that repository down, and as long as you have the images built locally, you can just do a Docker Compose up, and fingers crossed, it should work.
Any plans for official support of Sitecore Docker?
So we have support today. Sitecore is supported running inside Docker containers. We do have a caveat at the minute, so we're still along the journey of our Docker container support. So if you run into an issue that support can't create inside of a container, then they may ask you to try and replicate it outside of a container for now, just to kind of prove that it's not the container causing the issue. The level of support we have for containers is definitely going to ramp up through later versions. As I said, we want to basically have Docker images that we provide. Once we get to that point, then they have to be fully supported because they are provided by us.
Another question, is this only for development environments? What about production environments?
As I said, we do support Docker containers. If you want to push them out as far as production, you can do that. We have customers who run Docker in production today. But there is the caveat currently that if you do run into an issue, support may ask you to try and recreate it outside of a container on current versions.
Okay, a couple more questions. Is there a way to reset the containers to the original state, like lose all the DLLs, configs, items removed, and get them back to vanilla?
Well, that's one of the good things about Docker is you can just blow them away and recreate them. They're so quick to tear down and stand up again that you just issue a Docker Compose down, and that'd basically blow away all the containers for that architecture. Then you can run a Docker Compose up, and you're talking like minutes to do it instead of, in the old Sitecore world, you'd have to, in effect, basically do a new install, which could take quite a while.
All right, another question. Any plans for hardened containers? Containers configured according to Sitecore security guidelines?
That's a good question. I believe we would have to follow those when we create our own images. It's not something I've looked into ourselves yet. Good question, though. I'll have to look into that.
Any idea about support for blob storage, say for the media library?
So we don't have any images currently in the Docker images repository, I think, which have blob support included. But you could quite easily create your own. It'd be easy, for example, to take the XP images and then just create another layer on top, which includes the blob storage module. Like it'd be pretty easy to do. And then obviously you'd create a PR and have that pulled back into the Docker images repository so everyone can do it.
Another one just rolled in. This will be the last question. Is there a plan to officially support Docker containers in AWS?
So that's one of the joys of Docker and containerization again, is that basically our support of containers makes us cloud agnostic. So once you have a container, you can basically take it and run it anywhere. You can run it on Azure, you can run it on AWS, you can run it on Google Cloud. There's heaps of other container hosting providers out there. That's one of the advantages of bundling all this together inside a container, is it opens us up to so many other hosting providers, for sure.
Okay, great. I think that's all the time we have for questions. If anybody has further questions for Rob, you can reach him on Slack. Well, thanks again, Rob, for presenting, and good morning.
Thanks a lot.
Yeah,
Thanks for listening.
Thanks again, Rob.
Cheers. Bye.
Cheers, bye.
All right. Who's our next presenter, Mike?
Our next presenter is my other best friend down under, Alistair Dennis. We'll be talking
You
about.
got a lot of best friends.
I have lots of friends. I'll share friends if you'd like them. I know you love friends. Alistair Dennis at Sitecore. He's going to be talking about unit testing on Sitecore momentarily. Thinking about 9 minutes. So go get a snack. Go get some dinner if you haven't eaten yet. Do all those good things.
Snack, huh?
Get some coffee.
Yummy.
Donate.
And definitely donate. If you guys don't, it doesn't matter how much you donate. Any amount will help. You got to remember, this goes to people on the front lines. A lot of people are risking their lives to save others, and you don't want to be, that person where you end up, in a predicament where you can't get help because they didn't have the whatever it is, PPE, whatever it may be. So whatever you can donate, please do your best. It will help lots of people who need it. And we're dealing with very difficult times now.
Yep. And also, guys, as a note, the GoToWebinar has a questions tab wherever it's docked. So if you have any questions, feel free to ask your questions using that questions tab. We had about 220 odd people, got quite a few questions. You could ask a lot more as well. Yeah, and you don't need to wait until the end of the session in order to ask questions. You could start asking questions as and when when the presenter goes through a topic.
Let's all go to the lobby. Let's all go to the lobby. Get ourselves a treat. It's kind of like the old movies.
We can't hear you, Cam.
Oh, man.
An outfit change. Jeez.
Oh.
You did.
Oh, me? I just took off the lanyards.
Ah, nice.
Everything looks the
There we
same.
go.
Yeah,
We
I'm
do.
wearing
We do have the breakout
sun-
session available, right? The side room, if people want to join. The link is working now. It was a casing issue.
I didn't know that. So
Yeah, Bitly apparently does casing.
Oh,
so,
look at my SUGCH. Sug Switzerland brother. There you go. Shout out.
have you guys coordinated your outfits, or
I didn't. It looks like
if you could just grow a beard by the end of the session, actually, that'd be great.
Oh gosh, I just shaved today. I could never get a flowy beard like him. I wish, but I don't think I'll be any cooler.
You just don't have your whole heart into it.
Bruce, where are you? We just see your chair.
He's gone for a little swim.
Oh, nice.
It's underwater.
Alistair, are you on?
I am on now.
Yeah,
Let me check my headphones again.
sure. And then your webcam too, please.
We're not live yet, are we?
Question came in. It's actually common. I have a tan line from the sunglasses. It's actually kind of funny because You know, I mean, the only light I'm getting is from this light here. It's kind of like a, you know, or like you're at a police station. Hey, where were you on the night of whatever?
Ooh, yes.
I think it's just like an optical illusion. I mean, it could be honestly a sunburn. I'm not sure how though.
How's everything, Alistair? You're all set for your presentation?
Everything
so.
should be all right.
Show us some of that amazing Australian coffee. There you
You
go.
see that? I can't see
Damn.
myself.
By far the best coffee I've ever had in my life.
It is good down here. Yeah.
And I haven't been to South America, so once I go there, I could say that even more. Bruce tells me
They
New
grow half
Zealand's
a ton.
not bad.
All right, I think it's time to introduce our speaker. So we have Alistair Denny's here. He works at Sitecore, one of the smartest guys I know in the entire world. Back when I started on Sitecore, this was the guy to look up to. And I learned a lot from him in a lot of his posts over the years. Even had the pleasure of meeting him more than once. I'm not sure if he feels the same way, but he's going to talk about some great things on unit testing in Sitecore, which is definitely one of those difficult things that people, well, everybody has told me that they're very difficult to do, but it's all about clean code and doing things right and making things better. And he'll talk more about that.
Okay.
And I hope you sacrifice some coffee to the demo gods.
I did. Just barely.
I'll make you the presenter, Alistair.
Yeah, okay. Let me start the presentation and share my screen. No, I want to tell you which screen I want to share. So hang on there. Can you see my screen or am I not sharing anything?
I just see a connected to GoToWebinar screen.
Right, okay. Pause
And
the
it's flat
screen.
right behind that.
Let's try that one. Okay.
Yep, your PowerPoint is up.
Awesome.